Good morning. Okay, so this is going to be on electrolysis. Electrolytic cells are a kind of electrochemical cell. It differs in some ways, however, from the kind of cells we've already talked about. So the kind of cells we've already talked about are galvanic or voltaic cells. These ones produce electricity. They have a positive voltage for the reaction. Whereas an electrolytic cell, we need to supply energy. And we need to supply electricity by connecting it to our power source. The reaction is going to have a negative voltage associated for E naught. And from that tells you how much voltage you would have to supply to make a given reaction occur. With electrolytic cells, typically they're used to produce solid metal. So for example, we can electroplate, which is where you can put like a fancy metal on top of a lousy piece of jewelry. Like for example, we could take silver ions and add electricity to turn it into solid silver. And if we can make that happen on the surface of a less desirable metal, we can make it look like silver. Okay, so if I want to determine what the voltage is needed to make the reaction occur, I simply need to calculate E naught. So for this first reaction, I need to identify what's the reduction, what's the oxidation. This is a reduction. So when I do cathode minus anode, the cathode is going to be the copper reaction. So from my chart, I have copper 2 and copper here at 0.34 volts. My oxidation is going to be the gold to gold plus 3. That reaction's way up high here at positive 1.5. So this would have a standard cell voltage of negative 1.16 volts. So that means we need 1.16 volts to make it happen. Okay, that would be my answer to this part of the problem. I want you to try example 2. So pause the video, try the example, come back and check it. Within this compound, lead is +2 and fluorine's -1. So this is my reduction and this is my oxidation. Cathode minus anode. I need to find lead 2 to lead on here. Negative 0.13. And the fluorine reaction, because it's an oxidation, goes in the opposite direction, but I find the reaction way up here at the top at 2.87. This looks like it'll come out at 3 volts. If that's not true. Yeah, it is. Negative 3 volts. So we would need to supply 3 volts of electricity to make it happen.